Hi, I'm Michael with 1113 Solutions. Today, Nathan and I would like to talk through the features and value of the Needle Meter Setpoints tool. So Needle is a suite of products. We've released some and some are still in the works. Meter Setpoints, Meter Freeze, and Assistant are currently released, with Needle Analyst and Balancing coming soon. But today, we really like to talk through the features and the benefits of the Needle Meter Setpoints tool. Nathan and I have worked in the midstream measurement industry for years, and we know that flow cal exceptions can be frustrating. We can set the high and lows to a point where they're giving us false positives and our analysts start ignoring them. And then whenever there is a real exception, we end up ignoring that because we've gotten so many false positives. So we're going to talk through today how the Needle Meter Setpoints machine learning algorithm uses your historic data to set the high and low in flow cal so that whenever you get an exception, you know it's real and the analyst knows that they need to take action on it. How it works is you will produce a flat file that the Needle Meter Setpoints tool will consume. So through SFTP or a web interface, you'll provide that to the Needle SaaS application, and we will process that through our machine learning tool. Out of that, we will send back an SD loader file that can then be uploaded into FlowCal and give you new upper and lower control limits for your meters. The great thing here is that it uses historic data for each meter to set an accurate upper and lower control limit. Now I'm going to turn it over to Nathan. We're going to go through the machine learning model and give you a little bit of information of how it works.
All right. Well, thanks, Michael. So today we're going to actually talk about several different methods you can use to set your meter flowing parameter set points. That could be volume, differential pressure, temperature, you name it, even for your GC data. So the example I want to use here is from a normal distribution, is from a Gaussian distribution. It's ideal, best case scenario, especially for the statistical methodology. But what I want to first look at is if an analyst were to go to this data and do some visual analytics and have a graphical representation, I would expect they would choose limits that would be somewhere in these gray regions. Now, if I used a statistical methodology, you've often heard it's plus or minus 3 standard deviations. This one actually uses 4. I found that seems to be, with measurement data, especially hourly data, that seems to be the right number to use. 2 is going to be a little too tight. It's going to get you a lot of false positives, and 5 or 6 may be a little too loose. So if you can stick with 3 or 4. The problem with statistical, although it does actually mean something, it does mean that although it's not impossible to cross that threshold, it is very, very improbable. So that's something you want to look at. The problem with this, a statistical methodology, is it has to be a normal distribution or something very close to normal, something symmetrical that's also very close to normal. But problem with measurement data is our data is not normal. It's highly skewed. It's highly erratic. So statistical, I think, provides a good base, and we're going to build on that base using some machine learning, some higher level analytics. But it is possible to use this methodology if you do a data transformation, which is outside the scope of this video. Another common way for the industry is doing a simple non-parametric. So you take your data set and you name a certain percentage. So you're going to take a certain percentage from the top and certain percentage from the bottom. So this is based off of 2%. So you take 1% from the top, 1% from the bottom, and then you name, and that's where you apply your limits. The problem with this methodology, even at 2%, is you get way too many false positives. You get more exceptions or flags than you want to. Even at the lower limit of a lower threshold of 0.5%, it's not going to get you inside that gray region where we want it to. And what percentage would you apply that's going to work for all your meters, especially if you do a bulk methodology? So I would say stay away from the non-parametric method and lean towards something more statistically based. Now, this is an intermittent flow device. So if we if we actually apply our statistical methodology, it doesn't quite work. And the reason of that is because you can easily see there's two different clusters of data. Now, if we were to identify those, have an analytical machine learning based methodology to identify those, optimize those, and put limits across those different clusters, then you could actually choose the highest high and the lowest low. And those would be your limits that you want to set in your system. Now let's look at a more realistic example. So you can see this is actually pressure. It comes from a pressure transmitter from a meter. There's 3 different clusters. You can see those histograms on the left. And ideally, we want to have some calculation, some algorithm that's going to look at the data and put those limits within those gray regions that we expect using a visual analysis. We run that through an algorithm that actually uses 3 or 4 different machine learning models. And what we find is that the meter set point tool actually finds those different clusters and applies those limits appropriately after data transformation and optimization. So think about taking this methodology and applying it not just to one, but your tens of thousands of meters that you have, how much time and savings and accuracy you would get within that. All right, Michael, I'm going to turn it back to you. Thanks.
Thank you so much for your time and for watching this video. If you would like more information on needle, meter set points, or any of our other software solutions, please email us at sales@1113solutions.com.